Saxon Algebra 1/2 lesson 104. We are now at the end of week 2, my lovely students. Oh, I haven't been crossing off the past couple days. We've done 102, we've done 103, and now we're doing 104. That is the end of week 2. And look, we're already 1/3 toward our goal of surviving until summer. Yay! Okay, you've seen this before. You know that we can talk about the sides of a triangle and the relationship that they have to each other. We talk about, I'm trying to make it perfect. We put these little marks in to show that all three are the same. We call this an equilateral. Lateral means sides. Whoops. Equa means equal. So it should come as no shock to any of us that this triangle has 3 equal sides, right? Okay, that's cool. These little marks mean the same. So that's our way of showing that all of those are the same. There's another kind of triangle that's fun to draw. And in this triangle, 2 are the same, but the third one's different. This is called Isosceles. I know, the Greeks named them, and they came up with some weird words. Isosceles means 2 sides the same. Right? This guy's the oddball. All right? And then we have a third version that's called, it's hard to draw because they're so weird. Oh, it looks like an equilateral. Pretend it's not. Pay attention to the markers. This is called scaling. And what it means is each side different. Different lengths we're talking about. All right? So that's the third kind. Again, it's hard to draw because my brain just automatically tries to make them the same. Okay. This is classifying the triangles according to the lengths of their sides. Now, we can also classify triangles according to their angles, the size of their angles. All right? The first one that we like to talk about is the one that makes a perfect corner. We call that a right triangle. And a right triangle has one angle equal to 90 degrees. That's this one, right? Okay. Then we have what we call an acute triangle. All angles are less than 90 degrees, okay? And a lot of times we remember the word acute, which often means little. They're all small angles, less than 90 degrees. Then we have this guy that always used to threaten me strangely when I was a student. These used to just make me very uncomfortable, but you don't have to be afraid of them. They're fine. It's called an obtuse triangle. And in these, one angle is greater than, can you hear my washer? 90 degrees, right? This big daddy is more than just a straight up and down triangle, all right? So we know that we can classify triangles according to their sides and according to their angles, all right? And for some triangles, there's a special relationship. So I'm going to redraw the equilateral and the isosceles triangles on the next page because they're the ones that have a cool link between their sides and their angles. There's an equilateral. Remember, that means all sides the same. I'm going to have to pause, you guys, because my 2 little cats have come down and are standing by the door. Okay, wait right there. Hi, kittens. Do you want to go outside? Out goes one. Luna, are you going out? There you go. Be safe, little boys. Come back soon. My cats are the happiest cats in the universe, but that's because they're allowed to go outside and play in the daytime and sometimes at night, and I get really stressed because you know what? The world's not a safe place for little furry black kittens, but they're so happy, and that's because they're allowed to go out and be their little wild selves. So it's always stressful when I let them out because you never know, they might not come back. It's kind of like giving a teenager the keys to the car and saying, drive safe. Okay, so this is isosceles, sorry. Now, here's something that's cool. There's a relationship between the length of a side and the angle that's opposite it. Okay? This side and this angle have a relationship. This side and this angle have a relationship. But in an isosceles triangle, these two sides are the same, so that means those two angles will be the same. Okay? And that's what this mark means, is that these angles are the same. This one goes with this one goes with this one, but because these are equal, we know these are equal. What? Equal. So, equal sides means equal opposite angles. All right? That comes up again and again in our problems where we find out that these two sides are equal and this is the size of this angle, and that allows us to know the side of that one. Equilateral, the same idea exists. It's just a little harder to see. This, let me try different colors. This side goes with this angle. This side goes with this angle. Just pay attention to the orange, not the blue. And this side goes with this angle. Okay, so they're opposite, but this one, everything matches, so it's almost confusing. It's easier to see it here. In this one, because all three sides are the same, all three angles are the same, right? Equal sides means equal opposite angles. Okay, so that same rule holds for this. We'll talk about this more. It'll make sense as we go. It might feel a little confusing right now. Don't worry about that. 104.1. Find the angle, measure of angle. Oh, I forgot to tell you the most important thing. I'm going to draw a giant picture. No matter what shape the triangle, no matter how long the sides, no matter how they're configured, the total of the three inside angles always adds up to 180 degrees. Always, 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 always. There's no exceptions to this rule. Technically, they're called the interior angles, so we have to remember that, but I drew pictures of the interior. They always add up to 180. Burn it into your brain. Now let's do 104.1. We have a picture. You don't necessarily have to draw the picture in your homework, but I do recommend that if you're ever stuck, draw the picture. It'll help you figure it out. This is everything John's telling us. Find the measure of angle BCA. Okay, so I realize, okay, he means this angle, which makes sense because we already know the other two interior angles, so this is the third interior angle. Okay, what we know is that all three of these have to add up to 180, right? That's burned in our brains. I'll let you draw it again. Take a second to do that. So this one's 40, this one's 60. So we know that if we take the 180 total that they have to add up to and subtract the 40 plus 60, which is 100, that means that this angle And we can call it angle C too. John's calling it BCA. That's fine, but it's easy enough just to call it angle C. That must equal 80 degrees. And look, I'm just gonna leave my answer like that because it looks good. And that's correct, okay? This is what got us through that one. We have two more. What is the measure of angle B? Okay, I'll draw the picture so you can see it. I don't expect you to have your books with you when you're watching these videos. It's my job to show you everything you need to see. Okay, so we're supposed to find angle B. A says 50 degrees. C says 45 degrees. Okay, same truth. We know they have to add up to 180. We subtract what these two add up to, and that's 95. Right, 50 plus 45 is 95. And that means that our answer is 85 equals B. And I'm going to put a little degree sign on there, which is what I want you to do too with these answers. And that is also correct. Yay! One more. Angle B measures 110. Okay, let me draw the picture. B, A, C. Now this time, John put those little marks on there. All right, we'll figure that out. And it says angle B measures 110 degrees. What are the measures of angle A and C? Now, the normal student will look at this and freak out and go, I don't have enough information to answer this question. And I understand that. It feels like that at first. But actually you do, because here's the thing. B is up here. We know this one is 110. What do these little marks tell us? Oh, these marks tell us that this is an isosceles triangle and that these sides are equal. Okay, we know that there's a relationship between equal sides and their opposite angles, right? So this angle goes with that side, and this angle goes with that side. And so if these two sides are equal, then these opposing angles must be equal. And that means that A plus C have to be equal, right? A equals C. And we know that B is 110, so let's do this. We know they have to add up to 180. B is hogging 110 of those degrees. That only gives us 70 left total to go to A and C, right? And they're equal. So we just take 70 and divide it by 2. And that tells us that angles A and C are both 35 degrees. And that's the right answer. Does that make sense? It's kind of a fun little trick, right? This is the oddball angle. These two are equal, so that means their angles are equal. B is 110, so we subtract that from the 180 total. That gives us 70 degrees left to play with for the two of these angles together. And we know they need to be the same size angle because they're partners in this isosceles guy. So we just take the 70 that we have left, divide it by 2, and they each get 35. Yay! We're going to see a lot of variations on that kind of a problem. It's a fun thing about isosceles triangles. Right? And there's one like that in the review problem. All right? Sometimes John will tell us that these two angles, these two sides are the same length by the tick marks. He might also do something like this. Put, say, 5 and 5. That's another way of showing you, oh, look, those sides are the same length. So he can do it with what we call a tick mark, or he can do it with an actual number. Either way, it gives you the same important piece of information. This is isosceles, these side match, and so their opposite angles will also match. Okay, I'm done with 104. I hope you enjoyed it as much as I did, and I will talk to you on the video chat. Bye.